Physics Penguin.
Hello and welcome to Physics Penguin's Guide to Series and Parallel Resistors. This week we are mostly going to be looking at how we can combine components together in a circuit and what adding components does to the resistance of the circuit. Let's start with the series resistor situation. A series on the TV, like my favourite, Sergeant Seal and the Antarctic Crime Unit, is a group of episodes of stories that fit together one after another. There is really only one way to make sense of the series, and that is to start at the beginning and go through each episode in order. A series circuit is just a circuit with each component connected to the next to make a continuous loop in order. If there's only one way around the circuit, it's series. So what happens if you add stuff into a series circuit? Imagine a circuit with a single cell and a bulb. Well, you don't need to imagine because here's one now. Yes, that's right. Now, let's add a second bulb in series. So now there are two. So what happens in this circuit? Well, in the first version, the PD, the voltage from the cell, caused the current to flow all around the circuit, including going through the bulb. The bulb has some resistance, but this will be low enough to let the current flow and light it up. In the two bulb version, we've doubled the resistance because we've got two bulbs. This means that less current flows, so the bulbs will be dimmer. We can add more bulbs, but the circuit will just get dimmer and dimmer until we probably can't see anything at all. These are the rules for a series circuit. In a series circuit, the total resistance is just the total of all the resistances of each component just added together. And the current in the circuit is exactly the same everywhere in the circuit, yes, even through the middle of the cell. So series circuits are pretty easy to understand. It's just like a hurdle race, with each component being like a hurdle. The more hurdles, the harder it is, and the slower the race will be. So, what about parallel circuits? Right, well, parallel circuits are when components are added that create an extra route for current to follow. If the circuit has a choice of route from one side of the cell to the other, the circuit is parallel. In this example, the current comes from the plus side of the cell, but it could go through the first bulb, or it could pop along to the second bulb, or even just go through the third bulb. In reality, if the bulbs are identical, then they'll each get the same amount of current. I worry about that cell though. It now has to supply quite a lot of current because let's say there's 1 amp to each bulb. That means that the current going into and out of the bulb will be 3 amps, and that's actually quite a lot for a single cell. What if we add another cell in parallel? Will the current get less, like the series circuit? Well, no. With another bulb in parallel, you're just giving the current another route, and that'll increase the total current again. In this case, each bulb still gets 1 amp, so now the cell has to provide 4 amps. So what happens to resistance in parallel circuits? You don't have to do the calculation for this, but you must know that adding components in parallel reduces the resistance because we've already decided that the current was getting bigger. So what are the rules for a parallel circuit? Okay, well, the resistance decreases when you add more parallel routes for current to flow through. And the current in the circuit is not the same everywhere. The current through the power supply is the total of the current through all the routes in the circuit. And finally, a table of the advantages and disadvantages to each of these. So the series circuit, its big advantage is it's really simple to build. It's pretty easy to understand, really. But the disadvantage, Well, you can have everything on or everything off, but you can't pick and choose which parts of the circuit you want to work. Whereas the parallel circuit, you can control individual components. That's quite a useful advantage. But the disadvantage is it does get more complicated, and as we've seen, the current can get quite high at the power supply. You might want to think about those extension leads, and sometimes the current coming from multiple extension leads can get very high, and people sometimes get house fires if they're not really careful using them. So as you see, series currents are easy to make, but all the bulbs, or all the heaters, or whatever they might be, have to be on, or they have to be off. So that kind of limits their usefulness. Parallel circuits are very controllable, but also more complicated, and can give a high current, especially at the cell or power supply. Well, that's basically that, so pause the video and try the worksheet from the video description below. When you're done, unpause it and we'll go over it. Pause the video now. Welcome back. Let's see how you went on. Question 1 is just asking about two circuits. Which one is series and which is parallel? If there is more than one way around the circuit, it is parallel. So the left-hand circuit is parallel, but the right-hand one is series. Well, that was easy. Question 2, we have the same components in the circuit and the same PD from the cell, but which one will be brightest? Well, the 5-volt cell is split between the two bulbs in the right-hand circuit, so they get 2.5 volts each. So the current will be quite low. The right-hand circuit has each bulb connected directly to both ends of the cell. So the bulbs here get the full 5 volts each. The right-hand circuit, the parallel one, will be brighter. Now, question 3 is quite important. We have to complete a table again. In the first row, if you want to control individual lights, then series is no use. It's kind of all or nothing with series circuits, so we need a parallel circuit to control individual lights. In the second row, we want to place an ammeter. Ammeters measure current in the circuit, so we place them in series. In the third row, we need a voltmeter. Voltmeters measure PD across something, so you create a mini parallel circuit with the wires to the voltmeter connecting either side of whatever you need to know the PD of. So voltmeters work in parallel. Now, question 4 needs a calculation of sorts. This is a series circuit, so we have to add up the resistance in the circuit. Now, we have 700 ohms and 1300 ohms. That's what K means. 1.3 K is 1300. And that's all from the diagram. And the question adds to that, the bulb has a resistance of 100 ohms. So we just have to add up the three numbers. So that's 2100 ohms. Or if you want to show off, 2.1 kilo ohms. Question 5 is quite simple too. What happens when resistors are placed in parallel? Each resistor in series adds an obstacle to current. So series resistance increases resistance like in the last question, but in parallel each resistor adds another route for current to follow. It's like building more roads out of a town. You would expect traffic to leave faster. Adding resistors in parallel reduces resistance. Well, that's it for today. Please remember to subscribe if you want to know when the next video is available. Well done for working through this stuff. Until next time, this is Physics Penguin saying ta-ta.
Physics Penguin.